Hi everyone, welcome to tutorial 29 of our introductory Python for image processing tutorial series. Now in today's tutorial, I'm going to provide a few basics of Scikit-image based image processing. Now Scikit-image is one of the two primary libraries for image processing that we are going to use. One, of course, Scikit-image, and the other opencv. So the next tutorial is going to be about opencv. And today I'm just going to provide a few basics of Scikit-image because to cover the entire Scikit-image, it is a course by itself. It takes like a series of tens of videos to talk about it, which we plan on doing anyhow. So let me provide a quick introduction to Scikit-image in this video, and in the next video, opencv. And in the following videos, we are going to not look at our tasks as Scikit-image or opencv, but tasks as tasks that we need to do. For example, Gaussian smoothing or median filtering, or we know what task we need to do. For that, let's look at the right library that offers the right tools rather than the other way around. Okay, so let's jump in. And again, we already looked at how to read images using Scikit-image and opencv. So this hopefully would be a quick tutorial for you. Okay, so as usual, I have written a few lines of code so we save our time. So let me quickly copy and paste a few lines and then go through them. So first of all, I always, again, this is not the way I import it, from matplotlib import pyplot as plt. It's exactly the same as before, but this is a standard way or a better way of writing it. So pyplot is to plot, so we can look at our images. And from Scikit-image, this is the library. The way you import it is import Scikit-image, or from Scikit-image import the required modules that you want. So I'm going to import something called IO. Again, this is what we use to read our images. And I am also going to import color, probably because I'm going to do something later on with that module. Now, within Scikit-image, there is a module called transform, and within that there are various functions to do image transformation. And the ones I'm going to import for now are rescale, resize, downscale, local means. Okay, so these are the ones I'm going to import, and we're going to apply that in a minute. Again, please go ahead and look at the documentation for transform to find out more things that it can actually do. There is so much I can show you. So let's start by importing our image, and as usual, my variable is img, and I'm going to do io.imread, and my image is osteosarcoma 01, which is located in my images subfolder. And I'm going to read this as gray equals to true. So when I run this, you should be able to see up here in the variable explorer a numpy array. Sorry, I got blank for a second over there. A numpy array where all the values are float 64. Again, when you use Scikit-image to read an image and you try to do some sort of a conversion like this, like as gray, then the values will be a float 64, all the values between 0 and 1. So if I open this, you should see that all values are between 0 and 1. Okay. Float in Python can be any number. Again, if I just type float of 29, for example, it's 29.0. Float can be any number in Python, but for Scikit-image, when it converts an image into float, by default, it changes the values to 0 to 1, or rescales all the values to between 0 to 1. This is something you have to remember. Again, let's go ahead and remove that as gray part and run it again. Now you see that my value is unsigned integer 8 because it's not doing any floating point conversion. But the moment I put as gray equals to true, it does that conversion. Okay, this is an important thing to note because you may forget this when you do these conversions. Okay, so we already know how to read an image. What do we do after we read an image? Okay, so you can rescale, you can resize, you can do a whole bunch of I believe if you actually put anti-aliasing equals to true, it actually uses Gaussian smoothing to avoid anti-aliasing artifacts. So that's one note I took right there. And to rescale your image, all you need to do is just remember the rescale that we imported from here. You just take that rescale. Rescale what? rescale your NumPy array, which is our image right there, yeah, our image, and by what factor? 1/4, or you can just put 0.25 over there, okay? So rescale everything by 25% to 25%, and anti-aliasing equals to false. You can make it true if you want, and store the rescaled image in a new array called image rescaled. So if I run this, now you should see that my new image rescaled is 25% of my original size. Original size was 1104 by 1376, and this is my rescaled images. Okay, of course it's going to update all the pixel values and everything based on your rescaling. What else can we do? Let's actually do resized image. Okay, so now we are going to resize our image to a given dimension. Okay, so here I'm resizing it to 200 by 200. So if I actually run these lines now, image resized, you can see that my image resized is 200 by 200. Now, rescaling and resizing are pretty much doing very similar tasks, except in rescaling, you're just providing a scaling factor. In this case, the scaling factor is 0.25. In resizing, you're actually giving the output image size, dimensions. My output image, I want to force it to 200 by 200. So this is exactly what resizing is. And we can actually look at this image. There is a reason why we got PLT. So plt.imshow, if you do img, this shows your original image. Okay, so let's go ahead and run this. So this is my original image. And again, if that color scale is irritating, you can actually do your color map equals to gray. So you can actually see the output image in grayscale. Okay, so there is our original image. Now, how does my rescaled image look like? So here is our image. Oh, sorry, I forgot underscore. So image underscore rescaled. It looks very similar because it's scaled down to 25%, and I'm displaying it to the same size here. Now, does resized look the same? Image resized. Okay, let's run this line. And our resized image looks compressed because we are forcing our 1376 by 1104 image to be 200 by 200. So it kind of compresses this image. So usually rescaling is a better option than resizing if you really would like to resize your images. And one more thing, downscaled. So downscale using local mean of elements by defining a block. So let's actually do downscale images. How do you downscale? Again, downscaled image in a block of 4 by 3. So let's go ahead and do that, and let's look at our downscaled DOWN downscaled image. Okay, so again, it's actually stretching it to be a 4 by 3 format. That's what downscaling actually is. And again, go ahead and experiment with these operations, but most of the time I did cover these for the sake of completeness. The only thing I've ever used was rescaling. That's it, because for machine learning purposes you may have to rescale or crop a smaller section of your image, but almost I don't even remember when I used resize or downscale, but for the sake of completeness we covered it. Now, Scikit-image, these are the basic stuff. Now, there is a lot of advanced stuff that Scikit-image can actually do. I'll cover bulk of that in the upcoming tutorials, like I mentioned earlier, with very focused tutorials. But just before we end this, I just want to show you the capabilities of Scikit-image. Okay, so let me erase all of that. In fact, let's actually delete these two. So from Scikit-image, again, let's go through line by line. So from Scikit-image, import IO, because that's the way we can load an image. And from Scikit-image.filters, please go and look at the documentation of filters. They have so many. I'm going to import Gaussian and Sobel for now, so we can actually have a look at these two examples. So how do you apply Gaussian? First of all, let's read an image. How do we read an image? You know that. img equals imRead. You can read this as grayscale if you want, but I'm leaving it as is. So just look at this image so we know what we're dealing with. Okay, here is my noisy image. I added artificial noise to this image, so it looks pretty noisy. Now let's actually using Gaussian, and the way you define Gaussian is once you imported it, I'm applying it on my input image with a sigma value of 1 and mode equals to constant and cval equals to 0. What that basically means is my output image should be same as my input image. And I'm going to talk about this when we talk about Gaussian smoothing later on. And a constant value 0 means when you extend the frame because you're doing some convolution, add a constant value of 0 at the end of the frame. Okay, that's all it means. So don't worry about it for now, but the way you can implement is just by using Gaussian, and that's it. And if you don't put these mode and everything, it uses default values. So you don't have to worry anyhow. Okay, let's go ahead and run this and have a look at our Gaussian smoothed image. In fact, let's just plot this Gaussian smoothed image so you can see how the smoothed image looks like. Okay, not bad compared to the original noisy image over there. Okay, now of course you can put your sigma value equals to, for example, 2 and run these two lines, and you can see how the output looks like, a bit more smoothed right there. So this is how easy it is to apply Gaussian smoothing. Let's also do the same thing with Sobel filter. Okay. Again, we are reading our images. This time, instead of the noisy image, I'm reading a clean image as grayscale, and I'm because that apparently Sobel in Scikit-image only works on grayscale images. So how do you work with color images then? Well, there are multiple ways. You can extract each channel and apply Sobel onto each channel. Again, I covered this in the previous tutorial, one of the previous tutorials on how to split these channels. Or you can actually convert this image from RGB to some other domain, and then you can apply it. Again, I'll cover these later on, but don't worry about it for now. Let's go ahead and apply Sobel so we can look at some of the edges here. And this is how the edges look like on this specific image. Okay, so this is the power of Scikit-image. I know I haven't shown you a lot in Scikit-image, but I just want to show you, give you a little bit of taste and cover the rest of it in the next literally 15 or 20 videos that are upcoming. But in the next tutorial, I'm going to do a similar introduction to opencv, and then let's go into individual applications. Thank you very much.